For question 14, we're trying to show that when you draw the altitude to the hypotenuse, it's going to divide the hypotenuse into the ratio 1 to 3. So in other words, the ratio between BD and AD is going to be 1 to 3. And we're going to start by letting BD be x. And then this is a 30, 60, 90 as well. This has got to be a 30-degree angle. So what I know is that this piece has got to be 2x, this piece has got to be x root 3. And when I turn my attention to triangle ADC, I have the shorter leg of a 30, 60, 90. So in order to get the longer leg, I need to multiply this by square root of 3. So this is going to be x square root of 3 times square root of 3, which is just going to give 3x. So the ratio of the pieces is 1 to 3. I'm going to work backward and do 13 as well. So for question 13, we're using a coordinate plane, and you know on a coordinate plane, every time you plot a point, you create a right angle. So point D is up here, and what we know is that this is a 45-degree angle, and we have a right angle there, of course. We know the coordinate of point C is 1, 0, which means that we had walked over 1 unit to the right and then didn't go up or down at all. So I know that this is 1. Since this is a 45, 45, 90 triangle, this length has got to be 1. So in order to get to D, we go 1 over and 1 up. So D must have coordinates 1, 1. So that's part A. Find the coordinates of point D. If we want to find the slope of this, well, we know slope is change in y over change in x, rise over run, and that's going to be up 1 over 1, right? Change in y over change in x. So that's going to give us 1 over 1, which is 1. And if we're looking for the tangent of 45 degrees, the tangent of 45 degrees, well, you just read in question 12 that tangent is the ratio of the opposite leg to the adjacent leg. So this is going to be 1 to 1, which is 1. So the tangent of 45 degrees also happens to be the slope of that line. Interesting.